I'll just do a couple-minute intro about the group, and then Patrick will take it away. So this was the first slide to invite you to do the survey, and the result of the survey is still until the end. You may be winning a money book. I'm not going to go through the slide deck of serverless user group. I do it every time, so you can watch it in a past recordings of the past slide decks. And normally we have tons of meetups planned in the future, but summer is coming, like so much work. So we have a number of meetups on the go, but nothing firmed up yet. So one of the meetups is for Segment. We were talking about it before. They are the biggest kind of CDP platform, customer data platform. And they're going to explain this buzzword and the market and why and how to use them. And then we used to have Joe Amison, like when serverless just started, like it was like a gold rush. Everybody wanted to create business, to run something. One of the rare survivors or winners of that gold rush is Joe Amison. He has a major insurance company running totally serverlessly in Columbus, Ohio, now expanding throughout America. He's writing the book about the way he's running businesses and using serverless on that front. I'm joking that his serverless is jobless because he's running a huge company with almost no IT, just the business folks. But if you as entrepreneur mindset, you can copy his approaches and start your business. So I'm excited for him to finish the book and then talk to us about that. And then, Luck, he was here with us. He wrote this book, Data Science on Google Cloud. The second edition is coming to Canada on May 3. I invited him to talk, but he recently left Google, so he's right busy right now. So we don't know when it's going to happen and if it's going to happen. But timing would be perfect to summarize changes in this Bible that we use for 5 years now. So he has a new edition. And then I'm also talking with James and Dirk from Amazon about something about event-driven integration patterns. I love their talks and their knowledge. So they're going to share something throughout the summer. So that's what's happening in my head. Like you are invited to present about anything you're working on, as long as it's altruistic. We are trying to be more in service of business like this talk today. And you can get ideas at our YouTube channel to see what types of talk we had. And please rate our meetings on Meetup so more nice folks like you would come to join us. So that's what's cooking for the summer. And we may be skipping a couple of months. It's just kind of so much thing going on. And then we are grateful for Manning Publishing. They've been our sponsor like 3 years now. At the end of the meetup, whoever visits, finishes the survey, will be eligible for raffle of any of their products. And now, Patrick, thank you so much. We are honored to have you. Please introduce yourself. It's really honored to have you here.
Yes. So, hi, everyone. My name is Patrick. I lead a team at Google Cloud called the Specialist Customer Engineering Group for Canada. Basically, my team helps customers to understand our product and use our products better. I was mentioning a little bit earlier that today I'm talking about data, but I have a team specialist across everything that Google does, from data to infrastructure to application modernization to marketing analytics to everything that Google does. I've been at Google for almost 5 years. It will be 5 years in exactly a month, so almost 5 years. Building that team. And for those who have been in touch with Google Cloud Canada in the past few years, you know that 5 years has been a long time for Google Cloud Canada. When I joined 5 years ago, all of cloud in Canada, I was the 6th hire. And now we're about 300. So it was an interesting ride, growing that part of the business. Today I'm here, so Daniel invited me today to talk about Apache Beam and Dataflow. So let me share my screen real quick. I just need to find the right tab. It's always the fun part of sharing your screen when you have like dozens of tabs. Okay, there we go. Okay, so you should be seeing my screen now. So the presentation, of course, this is Google branded. So the presentation will talk about Dataflow. In part of the presentation, I want to make this clear and that this is really about Beam. This is really about the open source technology that's behind Dataflow. Dataflow is one way of running Beam pipelines. Dataflow is an excellent product. There is a lot of good things. It saves you a lot of trouble. But the strength here, the important part to keep in mind here is really the underlying open source Beam. I'll go through where it comes from. I will go through what's the architecture. We'll try to look through a few pipelines. And I have a live demo that I will be doing at the end of the presentation also to show a streaming pipeline. It's a live demo. I always like to do live demos. I like taking risks, so it might fail. I'm warning you in advance, but technically it should work and should at least give you an idea of what it looks like. I like to make those presentations, so I'm not very formal in my presentation style. You will see this. I like to make this interactive. Don't hesitate to interrupt me. Don't hesitate to ask questions. I will be monitoring chat also, but feel free. I mean, it's not a huge audience, so feel free to just open up your mic and ask any questions that you have during the presentation, after presentation, anytime. I also put my email in chat if you want to reach out to me. Feel free to reach out. You can find me on LinkedIn also. Again, I'm not always fast replying to emails, but at some point I do reply, and I like hearing about this. Before I start and before I go through my slides, yes, Panika.
Sorry, just a quick question. Would you prefer email over LinkedIn or Slack? Which would you prefer? Which channel is easier for you?
Email is probably the easiest channel. Slack, I have too many Slack rooms and tend to lose things in Slack rooms. So email or LinkedIn works also, but email is probably the best way.
Sure, thank you.
No problem. Because the problem with LinkedIn is that there is a lot of random messages also, so it's not always the top priority.
Makes sense.
Okay, and yes, we can batch questions at the end. That's true that for YouTube, that's better. So no worries at batching questions at the end either. But I will start with something a little bit more interactive before I dive into my slides. So you joined this. So Beam is a little bit outside. This is more on the data side than the serverless, more infrastructure that you talk normally. Is there any specific things that you would like me to cover? I talked about a few of those with Daniel earlier before people joined. But before I dive into my slides, any specific interest that you have in Beam that so I can make this as useful for you as possible?
If folks are shy,
that's fine.
We were talking before recording it about switching the mindset from batch to streaming mode of operation. So that would help many people.
I will go with that. And I'm used to people being shy. I taught university classes online for 5-6 years, so I'm used to talking to a mute audience. That's fine. That's normal. So we'll be talking about Cloud Dataflow and Apache Beam. So when you see Cloud Dataflow in the email, Apache Beam, the two terms can be basically used interchangeably. That's the same thing. So what is Apache Beam? Apache Beam is a way of bringing your data together. William, so Cloud, I won't do my slide in order. I'll just go and show you one slide and then I will go back. We're talking about Beam versus Dataflow. Beam is an open source framework that allows you to programmatically create pipelines, data pipelines. These can be batch, or this can be streaming, or it can be a mix of batch and streaming, which is an interesting part of Beam. Apache Beam has been open sourced by Google. Like a lot of our cloud products, it is based on a technology that was developed internally at Google for our own internal needs that we then open sourced and then turned into a cloud product. A lot of the products that you see on the market and a lot of the large open source projects that you see used, even in serverless space, Kubernetes, Knative, these kind of products come from this internal Google usage. So the problem that Google had internally when we developed what is called internally Flume, you might have seen this in literature somewhere, that was open sourced as Beam under Apache, is that Google has a lot of data. That everyone knows that. And Google has a lot of data in a ton of different formats coming from a ton of different places at a ton of different speeds. From the extremely massively fast, when you look at search data, just the volume of that pipeline is humongous. It's ridiculous. All the way to data that can be much slower. So data that we get from partners, some events, there is weather data, there is network data, and we needed to find a way of being able to play and integrate that data together and make it work so we had the output that we wanted. So we developed that framework that, again, internally is called Flume, externally is called Beam, to write those pipelines and to have a programmatic way of transforming that data. This also tied into Google's approach to data governance, where we try to always have a programmatic way of defining where the data comes from, where it goes, which solves some data governance issue. It's not to talk about data governance. Data governance will probably put everyone to sleep, so I won't get into that. But there is elements, if you're interested in data governance and how you manage to follow and track data through its various iterations and various versions, there is a lot of interesting things in the way that Beam is approached. So ping me or email me if you're interested in that. So that is Beam. Cloud Dataflow is a Google product that can be used to run Beam pipelines. When you write in Beam, Beam is an extension. It's an API that exists in Java, in Python, and in Go. And other languages might be coming, but these are the three mature ones for now. You need to run that pipeline on something. You will use Java, Python, Go to create that pipeline, to define where data comes from, where data is going, what you want to do with it, how you want to transform it. Once you've written that, you need to run it on something. And you need to run it on something that can parallelize. Because the strength of Beam, and I'm going a little bit, again, off my line here, but I'll get back to my slides. That's fine. The big strength of Beam is the ability to parallelize this. Because, as I was saying, the issues that we're trying to solve when we built that was that we have a lot of data. And there is no way that we can sequentially handle all of that data. If you think about clicks on Google search, the amount of requests of clicks per second that we have is just too much for one sequential process pipeline to manage. So Beam, those pipelines that we wrote, will be parallelized and can run on a variety of what we call the runners. Spark is an example of a runner. Flink is an example of a runner. You can run it just plain Java. It won't scale very well, but you can. Cloud Dataflow is one of those runners. So once you've written your Beam pipeline, you can decide where you want to run it. You have your own Spark infrastructure. That's perfectly fine. Run it on Spark. With your own Flinks, that's fine. Run it on Flinks. What we see, though, is that there is a lot of people writing those pipelines that don't want to manage that infrastructure. Because running Spark is not trivial. Running Spark at scale is very, very complex thing. Running Flinks at scale is a very complex thing. Dataflow allows you to serve as that backend that will run and parallelize your Beam pipelines. So you can run them. And this is, as a service, I'll show you the interface a little bit later, super simple. So you can start and just running the pipelines without worrying about the infrastructure. But nothing that I will be mentioning today on the Beam side is tied to Google Cloud Dataflow in any way. You could run the exact same code that I will be running later and run it on Spark, and it will run just the same. Does that explain at least a little bit the architecture? I will get back to this a little bit more as I go back into the flow of my slides, but does that make sense at high level?
Yes.
Excellent. So again, data everywhere. We have a ton of data, and who wants all of that data in real time? Everyone does. So that's the thing. Everyone wants all of the data all the time. That's what all of my data analytics specialists tell me all the time. So that's the problem that Google was having also internally when we developed Flume. How do we bring that data? And here we talk about real-time data. But we all know that real-time data is not the only type of data that exists. There is real-time data, there is streaming data, there is some complexity to that, and we'll get to that, but there is also batch data. I was saying earlier that some of the data that we were handling internally came at different speeds. I mentioned a lot of streaming speeds, but there is also batch speeds. We have some third-party agencies that we use for trading ad space, basically, that will just send us a daily dump of what happened during the day. That it's not streaming. But another one will send data in real time. At some point, all of the data that comes from all of the spectrum from extremely massively fast all the way to daily dumps, which you can, well, I guess it could be weekly dumps that would be slower, but it's not much slower. Batch is very slow, and you want to bring this all together. The goal of Beam is to try to help you solve that problem and not have to worry about the speed at which the data comes in. Worry about what you want to do with the data, worry about how you want to transform it, how you want to analyze it, where you want to send it, but completely abstract, 90% abstract, the speed at which the data will be coming in, and worry really about your transformations and what you're trying to do. So from the point of view of anyone who would be using the data output from Beam, from Dataflow in that case, it's like the data is coming in real time. There is functions to allow you to reframe it. There is windowing. There's a lot of things. I won't go into all of the details, but every data is seen as streaming data. If it comes from batch, it will just be interwoven into what you're doing, using the same code, using the same transformations, using the exact same approach that you had before. Does that make sense this far? Is this interesting? I know that asking that is not the best for YouTube, but I'm trying to at least keep. So the model that we're using in Beam is called a lambda model. A lambda model is basically where we inline as data stream in, as data gets in, regardless again of how it gets in. We don't care about where the input is. We treat it as it go, and this is a parallelized lambda. The original Flume inside Google ran on the original research version of MapReduce. So it is a way, and for those who don't know MapReduce, I know it's not everyone is a data person here, but it is a way of rewriting data problems so they can be run in parallel on smaller subsets of data, so you don't have to wait for the old data set. This is very useful when you have two large data sets. So events that are coming in, you stream it as each packet of information, as each small element of data comes in, the function will be executing and will be running on this and will be outputting on the other side. Little bit, I know it's a little bit high level, I know it's a little bit abstract for now, but we'll start seeing some pseudocode in a couple slides, and I think it'll start making more sense. So this is what we try to do. We have the model with Beam now. What we have here is just Google Cloud Platform. So again, Dataflow is just a way to run this. I need to spend at least a few minutes talking about what is behind Dataflow. So I mentioned that you don't need to run everything on Google, but I still work for Google. It's still my job to talk to you a little bit about the Google product. So Cloud Dataflow is basically all of the infrastructure that you need in order to be able to run your Beam pipeline as a service. What does that include? That includes all of the compute that you need, all of the storage that you need, all of the optimization elements that will allow you to run your functions earlier, and all of the automation to scale up and down and version your pipelines as you put them into production. This is basically a one-click. We'll actually do it with 3 clicks later when we will be spawning one. But this is a way of handling this. So again, if you are in a position where you want to write pipelines, Pranika was talking about the personal projects that she has earlier. Parnika probably doesn't have time to set up Spark and do all of those things because that's complex and not very value added. Dataflow is a very good element for this. And I saw you unmuted for a second. Did you have a reply to that?
I mean, I'm actually trying to figure out if I want to invest the kind of time in setting up like Spark, because I do want to learn about, I have some interest in data engineering as well. So scaling, managing, administration, all of it is something that I'm interested in. But yes, it is a lot more work. So I'm trying to see my best options.
It is a lot of work, and my opinion, and that's my opinion even regardless of Dataflow or Google, this is really my personal opinion. There is, right now, so if you look at the market in 2022, we're in April, almost in May now. I'm starting to see 2022, not 2021 anymore. There is much more value in understanding how to use those data tools than how to manage those data tools. There is more and more, and Google is one of the vendors, but there are other vendors that are extremely good at managing the infrastructure. And there is, if you obviously have a limited amount of time to learn, I would learn the data engineering part rather than the infrastructure and the management part of all of this, because again, all of the vendors will start having managed service that will abstract a lot of this. And this is what we see not just in data, this is what we see everywhere. I mean, there's a reason there's a serverless Toronto meetup. A lot of the push behind serverless is to not ignore, I want to be careful with the words I use here. All of that infrastructure and all of that optimization behind the scene is extremely important and extremely complex. It is just, since it is extremely important and extremely complex, specialized organizations tend to be much better at doing it than most. One question that we were discussing a little bit with Daniel before people join is, when do people decide to move what they have? Let's say that you're an organization that has a Spark installation on-prem, or you have an old Hadoop, well, old, not that old, but you have what is now considered the legacy Hadoop in a cloud era or something like that on-prem, and you're moving to the cloud. When do you lift and shift? And when do you just go and move directly to managed services? And some vendors will give you different options, but the reality is it will depend on how good you are at managing that infrastructure. And when we look at customers and when we work with customers, the answer normally is that most people are way worse than they think they are at managing that infrastructure. So the cost of not rebuilding, because you never rebuild from scratch, you modernize. The rebuilding from scratch doesn't exist. You build something with your startup, you don't rebuild from scratch. But modernizing and moving towards managed services at different level of abstraction will gain you much more value, because you will stop wasting your time on things that are, again, critical. I mean, SRE teams are critical. They're probably some of the people who do the most complex job we have at Google are SREs, trying to keep all of this running all the time. But it's such a specialized knowledge that unless you have a team that's as strong as ours, you're probably doing a worse job. So this is why those managed services are very valuable. But then again, I'm going a little bit outside of Beam now. I tend to do that. I told you I'm not very formal in my presentation style, but that's my opinion on all of this.
I'm loving it. We call that serverless mindset.
Yeah. Okay, that's a very interesting question, William. And so if we talk about GCP services, first of all, it's totally normal that you're confused. Google is good at a lot of things, but naming products is not one of those. So products names are just a mess. Dataflow is a managed service specifically to run Beam pipelines. So Dataflow is a Beam runner as a service. You cannot do anything else in Dataflow than write a Beam pipeline and deploy it on Dataflow. This is already a lot because you can do a lot with B pipelines, but this is the goal of that product. Dataproc is a managed Hadoop or Spark instance. So if you don't want to move, let's say to move to Beam, you want to run some things in Spark, but you don't want to manage your own Spark. You want Google to manage it for us. Dataproc is a product to do that. This is similar. This is slightly more complex because Spark does more than just Beam, but this is a similar approach. If you're in the serverless world or the container world, Dataproc is like a Kubernetes engine for Spark. So you go, you create your Spark cluster, you set up the sizing, all of the infrastructure part, but you don't have to update it, you don't have to run it. Data Lab is another managed service. There's a lot of managed services there, specifically around Jupyter notebooks. So if you have a data science team that wants to use notebooks, and we'll use a little bit of this later when I get to the demo, you can run those in Data Lab, but this is a way to host your notebooks. There is less to Data Lab than the other two products. It's mostly VMs with no notebook software pre-installed on them. Now, I think that explains the slide I had around what is cloud data flow. Now, talking a bit, and this talks about data flow, but this could very well be Beam. What you see here is what we were saying, that what I was saying earlier, that you can use the same data flow or Beam pipeline to basically merge data that comes at different speed. So what you have here is that you have some batch data here. This might be in one database. This might be a file, an Avro file that was just dumped. And you have a unbounded, this is a term that we will use when we do the demo earlier. You have basically a endless stream of incoming data. So one of that data set is what we call bounded. So there is a bounds. You know when that data set starts, you know when that data set finishes. And you have another data set that includes data that is the same. You see the same little squares and triangles and circles there. But that other stream of data is unbounded. There is no beginning, there is no end, there is just data that is coming in. What Beam will allow you to do is to take those two things, push them into cloud data flow or any of the other runners that you might be using, and make transformation and use any number of primitives or custom transformations on that. There is a lot of things that you can do with just primitives. You might want to sort, you might need to filter, you might need to window, you might need to just put things in order. But in some cases, and we will see it in the example I have later, you might also be trying to call another API. The example I do at the demo, later we'll actually be calling our NLP API, Google's NLP API, to do sentiment analysis on tweets. So you might be wanting to do that. You might be wanting to do a lot of different things. Regardless, again, of where the data comes from, those primitives or those custom transformations will be applied in the exact same way. That will give you one data set as the output, regardless of the speed or type of data that's coming in. So that's really the strength behind Beam and Dataflow. Why use Dataflow rather than another runner? Because again, I need to do at least a little bit of Google stuff. Fully managed, I mentioned this earlier. There is some auto optimization that is done in Dataflow that will allow your pipeline, in theory, as any auto optimization is not magic. It will not turn bad code to great code, but there is some optimization that will reconfigure your pipeline to try to have the most efficient path through your transformations. This is something that, especially in complex pipeline, can make a huge difference. There is auto scaling. So depending on the amount of requests that you get, you can scale up and down the cluster automatically, so you don't have to worry about sizing. And it also, as you scale, you can do dynamic work rebalancing. So that auto scaling can allow you to while a pipeline is running, make it faster or slower, depending on the amount of data that's coming in batch, the amount of QPS that you might be getting in streaming. So it allows you to choose and vary the speed of your pipeline. Again, these are things that could be done with other runners, with Flinks, with Spark, with others, but it's pre-configured, it's out of the box in Dataflow. Since I want to get to the demo, I will not go through the details of what all of this, of what autoscaling is and what rebalancing is. You're doing serverless. You probably have seen those concepts before. What's this stack? What does Beam look like? So I was talking about runners, and I was talking about libraries and Python and Java and everything earlier. What does that look like? What's this stack? I probably should have started by this slide, actually. So what do you have when you're running a Beam pipeline? So you have first an execution environment. That's your OS. So this runs on hardware on an OS. This runs on servers. It's serverless, but serverless just hides the servers behind some. it doesn't actually remove them. On top of your execution environment, which is your bare VM, you have what we call the runner. The runner is what will execute the code. I mentioned it before. Different options here. You might have Dataflow, you might have Spark, you might have Flinks, you might have a number of other ones. On top of this, you have what we call the model. The model is the transformation graph that you are building for your data. So Beam uses a concept that's called a directed acyclic graph, which is a very complex way of saying that it's a series of operations. So you are, and we will see some DAGs later, but this is a common data concept where you basically have a different set of organizations. So it's a graph. So this, before that, merge with that. And it is acyclic in the way that there is just one path to go through the graph. So you will never circle back. Regardless of the language that you're using, of which SDK that you're using, the model that will be outputted by this is the exact same. So what your SDK does, it allows you to create a Beam model in the language of your choice, but Beam runs the model, not the language itself. So the language and the SDK that you're using is mainly to define what that directed acyclic graph will look like. And when I was talking about optimization earlier, this is what our graph optimization algorithm does to try to put those in a better order, if it makes sense. How do you write your model? You write your model using one of the SDKs. Right now, 3 languages that are supported by, well, 3 that are mature, and I know there are some others coming up. Java, which is the mostly used one for large Beam pipelines. This is the only one that was available initially. That was the first one, so it's by definition the most mature one. Internally at Google, if you look at Flume, again, the technology internal that is behind this, Java is what is mainly used. Python is the second one. Python is newer. If you had asked me 3 years ago if I recommended Python for Beam, I would have said no. 3 years later, nowadays, I would say yes, and my demo that I will show later is actually in Python. Advantage of Python over Java is, well, it's Python in Java. It's pretty clear what the advantage is. People don't like writing in Java just for the fun of it. The disadvantage of Python in Beam specifically, because there's always pros and cons, is the fact that Python is not a statically typed language makes it riskier for data transformation use cases. There is a lot of work you need to do to just pass type hints from one function to the other, so you don't end up processing the right type of data. Java, being extremely formal in the way that it handles typing, has some advantages. There's less danger to have weird data coming in. But again, it's much, much faster and much simpler to write it in Python. Go is used a lot on infrastructure things. It's a nice language for this. I'd say it's the SDK that is the least mature at this point, but it's still a good SDK. It's still an SDK that's mature. It's the least one. So that's the language-specific SDK. This is how you will tie in Beam's API. to define those functions, those things. Yeah, that's and again, to answer maybe this question in a little bit more depth, Java versus Python. Most of the prototyping that we do is done with Beam on Python. I'm working with several customers working prototypes right now, and we do it always in Python because it's just less trouble. It's just easier to do. If I was to write something that would run at very large scale in production, I would probably not do it in Python. I would probably do it in Java. When should you switch is a very subjective thing. You might not know exactly when. You don't want to work too much on Python just to translate to Java. If you are very, very familiar with Java, if you're a Java developer, I would say go Java all the way. If Java will be a hindrance and you're running small-scale test playing, I would start with Python. But keep in mind that Python is slower. But yes, so Go is performing the fastest, but is a less good language for data processing. It hasn't been built for that. Java is actually faster than Python in this case, because Java runs natively on Spark and on Dataflow. So Java will be faster than Python. Java also has very strong static typing and is much, much, much safer. You cannot mess up typing in Java. It won't even compile if you mess up typing in Java. So you will never have an issue getting, when the data starts coming in, that your pipeline will crash because the typing is wrong. And when you're running at large scale in production, the fact that it's fast, I mean, it's still Java. It's not as fast as Go, but it's still faster than Python because it's not interpreted. And the fact that the type is safe is good. But yes, your pipeline will probably be like 5 times more lines of code in Java than in Python to do the exact same thing. So that's something to keep in mind also. Does that make sense?
Sure. Yes. Thank you.
Excellent. So on top of this, so that's the language-specific SDK. Again, this is how you will explain to Beam how to build its model. On top of this, you will have libraries. Libraries are basically your toolkit of transformations, sources, so how do you read the data, sinks where you send the data, and all that you're doing with that data. And on top of this is your pipeline. So as you're building, using those libraries to put those building blocks into a language-specific script that will run, that will define the model, this is what you're building, and that will be your directed acyclic graph at the end. In terms of stack, in terms of how this is built, does that make sense?
Yes.
Excellent. So what does that look like? That looks like this. And this is actually Java. I thought I had an example in Python, but it's in my demo. This is an example in Java. And as you see, since this is a high-level library, and you have like a lot of abstraction layer, you have like the libraries that abstract the SDK that abstracts Beam, it doesn't look that much like Java. It looks almost like pseudocode at this point. That's a good question in chat. There is no easy way to port Python Beam to Java Beam, sadly. So what do we do? What does this do? So this does something very simple. What we're trying to do here is that we're trying to get streaming data. So we're reading from Google Cloud PubSub, which is a standard messaging queue. You might have used Kafka or some other messaging queue concept, exact same element. We're getting data streaming in. We want to do a few transformations to this. We want to window them. So when we say window, we want to basically cut this into 1-second windows. Take all of the message within 1 second and put them together. We want then to create key value pairs. So we will take that message, we will create pairs out of them. We will count the number of entries that has the same key, format for an output, and then write back to another message queue. This is a very, very common summarization pipeline. So you have data coming in, you want to transform, you don't want every single piece of data, you want to know how many people clicked within 1 second. You will get all of that. So what we're doing here, starting our pipeline, and I know it's a little bit boring to show you a slide with code, but that, in my opinion, that helps understand the model. So I'm creating a pipeline. I'm applying, when I say that I apply, this tells Beam that I'm creating one step in my graph. What I'm doing here, I'm applying a function. That function is just pub_sub.io. That's the library. If we go back to the stack earlier, apply is the language-specific SDK. The library is pub_sub.io. What does that mean? That means that someone built a source plugin per the library to be able to read from pub_sub. This part, right, and this is something also that we discussed with Daniel. You will see a lot of functions in here. You will see pub_sub.io here, pub_sub.io there. You will see the fixed windows. All of those libraries basically exist. You will see people sometimes that are hiring for Beam or Dataflow related work that will ask you about creating custom sources. How do you... Reality is that it's not that important to understand how to create custom sources. Very few people do. I mean, some people might, if you have a very proprietary database system that only, but that's very rare. Most of the time you will be reading from well-known sources in well-known format, doing well-known transformation and writing to well-known formats. So don't worry too much, because when you start looking at the Beam documentation and you go into understanding how those SDK level primitives work, how do you create an IO? How do you create a source? How do you create a sink? How do you create... This is complex. Most people who will be using Beam will never have to do this. There is a ton of pre-existing libraries for most common formats that you will be using. So I would not worry too much about that part. You see here, I'm reading from pub_sub. I didn't figure out how to read pub_sub. I'm not even worrying about a pub_sub API here. I'm calling pub_sub.io, library that's maintained by Google in that case, because that's Google product. I have Kafka.io, that's the same thing for Apache Kafka. I'm saying that I'm reading. I'm giving a name to my function. This is just for documentation. This is just for display. And then I will write configuration. So the topic, which is the message queue that I'm reading from, is called this. There is a timestamp label that says TS. So TS is this timestamp for the time. And it will be JSON rows that I will be getting. So what I did with just this first few lines of code, and again, this is Java. It's very, very short, very concise for Java code. I've connected to my queue. If I'm running on Dataflow, I'm already authenticated. I've gotten the message in, and I've decoded the JSON into a Java object, considering the fact that I say that it's a table row JSON coder. So all of this now, will be sent to the next element is a series of singleton, a series of objects that will be the decoded JSON object that I got from pub_sub. Again, what I do to continue, I will start building more steps into my graph. So I said that I wanted to group those by 1 second. I want to group those by 1 second intervals. Again, using the libraries on top of the SDK, I will apply to the output of this window into duration of 1 second. What am I getting here? So what's the output of this? The output of this will be a series of objects, but rather than be a series of singletons like I had earlier, it will be a series of collection of objects that includes all of the objects within that 1 second window. So again, as I write and as I go through that, I don't have to worry about the transformation that I'm doing here. I don't have to worry about putting those into collections, about worrying about the timestamps, about doing all of this. I'm receiving a stream of single objects. I'm telling my pipeline just group those in 1 second, and the pipeline will know how to send collections to the next step. That might highlight a little bit, though, why I was saying that Python can be dangerous in those cases, though, because in Python you need to be aware of the fact that this is happening. But that explains. And now what will I do? I will keep applying functions. I won't go into all of the text here necessarily, but I will keep creating applies to do a map elements. Map elements will create KV pair. I will count. So now I'm receiving a series of key values. I will be counting per key. So I will be receiving a series of counts. I will be applying a custom transform here, and I will be writing back. So when you're writing Beam, you're really worrying about what's happening to the data. What's the pattern? What's the type of transformations you want to do? You don't worry about all of the complexity of encoding, decoding. How do you put this in collections? How will I parallelize? The fun thing about this is now you're seeing this. This looks good, but when we run this in Beam, this will actually be parallelized. So when I say that I'm doing, so windowing is not parallelized for obvious reasons. But when I'm saying that I'm mapping here, I might have one machine doing my key values, or I might have 10,000 machines doing my key values. As I'm writing that pipeline, I'm not worrying about that. I say to Beam, go, do a key value map, and the model will figure out how to best use the infrastructure that's available. And again, this is very powerful because as you are working on your data pipelines, you're thinking about your data. You don't want to think about all of the complexity infrastructure behind this. That's not your role. That's not what you want to do. So Beam will take this for you. Does that make sense? Is this useful?
What's the use of the word ride there? What is a ride? Is it a group of records, a block of records, or is ride just the sample data you happen to be talking about?
That's the sample data that this pipeline was built to process.
I see. So it's like a Uber ride or something.
This is so. There's a link at the end of this to the full lab around this, but this is taxi rides in New York.
Okay.
So we have a huge data set of every taxi ride in New York. And this is what this was reading. Basically to do travel time estimations. So this is all nice and good, but that's still code to write. We still need to go and write this. If I move a little bit into more of a Dataflow feature on top of Beam, Dataflow adds something that is called Dataflow templates. One thing that we figured out when we were looking at the pipelines that our internal users and that our external users were writing in Beam is that a lot of things, a lot of simple use cases are the same. There is a ton of people that might just be taking streaming data from Cloud PubSub and sending them to BigQuery. There might be a lot of people who are just doing some key value grouping on things. And what this meant was that a lot of people were writing basically the same pipelines. So what we added there as a feature into Dataflow is that we have what we call templates. Templates are basically one-click ways of not just setting up the infrastructure, but creating the pipeline also. So let's say that I have some data coming up from PubSub and I want to send them to BigQuery. I will show them quickly in my demo. I don't want to spend too much time because I'm already at 7, but I will show it in demo. We'll create one later. I want to take data from PubSub to BigQuery. I don't want to write a pipeline for it. I just fill out this form, click Run Job, and it will start a pipeline that will be running and doing what I configured there. Those templates, there are some that Google has defined, but there is an API for those Dataflow templates also. So let's say that you are managing it. Let's say that you're part of the data science team for a large organization. And you know that a lot of your business users might want to run some transformations on their data. And you know that there are some common use cases. You don't want your business people to come to your data science team for every single simple pipeline. you just won't scale. There's just no way. You want to do interesting stuff, not just write the same pipeline over and over again. It's very possible for an organization to just define their own template, which are written basically in the same way that you saw with the pipeline I had a few slides ago, with some configuration around it, and publish those templates privately to your organization. So you have someone, I had an example in banking recently where they have a lot of internal systems and wanted to be able to take data. Someone in your loan department wants to have a data to be able to get customer data from place A and send it to place B. They can go choose the template from the catalog, just enter their information, and the pipeline is created by itself. This is also a very, very interesting feature, both for the ease of use of pre-built templates that Google might be providing you, and both for the option of yourself also creating those templates and creating a catalog of things. It allows you to scale your data science team much better. And again, focus on the interesting stuff you want to do, not on writing the same queries. This is less interesting. So what does that look like? And actually, you know what? I will skip that part because we will go to the demo. And I will show you not slides of what the UI looks like, but what the actual UI looks like, which is always a better experience. There is a few links here. I see that I know you can't click the links I have on my screen, but at the end, what I will do is I will share with Daniel the links so he can share with the wider group. So let me just stop sharing and start sharing my other window. Let me show you a little bit what I have. Okay. I can't. Okay, I'll need to share per tab because macOS changed the way they do permission for screen sharing, and that I just updated and it reset it, and that's a mess every time. So sorry about that. I will have to stop and start sharing a few times when I'm changing tabs. So what you have on the screen right now is the Google Cloud Console. Basically, that's, and I'll run my demo on Google Cloud for very obvious reasons. But again, this all could be done in other systems. Now, what does that look like? A few products that we're using in the demo. What my demo does, there is basically a quick Python script that runs on a machine that reads tweets from Twitter. Try to find tweets about pizza, because I was hungry earlier when I built that demo, and runs this through natural language processing to try to see if the sentiment about the pizza that's been tweeted about is good or bad. So that's what the demo does. There is a few things that we're using here. We will be using 3 products within the Google Suite: Dataflow, BigQuery, and PubSub. What PubSub does is receive the tweets. So there is a script that runs that send them to PubSub. Dataflow will allow us to do 2 things. We will have 2 pipelines running in this demo. The first pipeline will just very simply take the tweets that are coming from PubSub and send them to BigQuery. That's the simplest one we'll do. We'll use a template for this. The next one will actually be taking the data in BigQuery, processing it through natural language API, and write some additional data. So what we call the data enhancement in that case. We will add some metadata to the data that we have. So that's the 3 products that we'll use. So first thing that we'll do, we'll come here and we'll go and see our queue. I have a few demos in this project, so I have a few things. So you can see here that I have a certain number of messages that have been coming into my pipeline, into my queue, my message queue. I'm still hungry, so I might start missing some words there. I'm talking about pizza now. So there is data that are coming. I have about 1 message per second average. If I look at the graph here, over the past hour, it's been running for about 2 hours. If I go back to the top of my screen, though, there is an error here that's telling me, okay, you're getting messages, but you're not doing anything with it at this point. Right now, I'm just receiving message in message queue, and I'm basically dropping them because I'm not nothing is subscribing to it. So the first thing that we'll do is that we will use Dataflow to create a pipeline to solve that issue. I'm getting messages. I might as well do something with those messages. How will I do that? I will use the little template magic I mentioned earlier. So we'll go here and I will click on that big export to BigQuery button. And what that does, it allows me to create a Dataflow job. What I will do, I will go and choose where I want to run it. I will run it in USD4 for random reason. I will run this. My input is the queue that I had. This was auto-filled because that's the queue that I have. And I will go and create, I already had a BigQuery table for this, but I can't for the life of me remember how it's called. So I will go and look at my table name here, tweet NLP demo. That was simple enough. I should have remembered that. I will still copy it because knowing myself, by the time I'm switched to my other window, I'll probably have forgotten about it again. So we'll go back here. Again, live demos. We can't expect every step to just work without me forgetting anything about it. Export to BigQuery. I'll go here. Oh, and I need a temporary bucket. That's true. I will go create a temporary bucket. So I will go and create some cloud storage. That's just for staging. That's just to basically for the template to upload the script. And I thought I had done that, but I did not. So let me go and create my bucket in the right product. So if for some reason my computer is end of life, I have like 2 weeks before I can request a upgrade. And it's starting to show when I'm running multiple stuff at once. So storage. We'll go and create a quick bucket. Bucket is just object storage. So this is just a place to store files, basically. And this will be used not for the data itself. This will be used by Dataflow to basically store the script that will be run. I will try to call it this, but this is world unique, so I will add my name to there. And I will just create this. And now that I have my bucket, I will copy the name, and I will go and finish my template. So let's go here, and I will, no, here in my topics, we'll go into my demo. I will export to BigQuery. I have all of the information I need now to create my template. I will create my temporary location. So that will be a Google Cloud Storage. So that yes, -- we'll put it at the root. Don't care, there's nothing else in that. I will call it, it's enforcing best practices. I shouldn't put this at root. The name of my table was this without my username there. We'll call it table. Why is my format not? Oh, I need to put my, sorry, I need to make my project name. Cloud Lab 1138. Why can't I find the right? Okay, sorry, I'll go back to BigQuery. Again, live demos. Sorry about that. BigQuery, what do I have and what's the table name real quick? So that's the name of my data set. And I have not created my table. Create one that will called I'll go to the details. This is the full name. So if you were worrying if I was honest when I said that I just built this earlier because I was hungry, you see I didn't even do all of the stats. So that was not a pre-built demo. I just cooked something earlier when I was trying to do this. That's the proof. So that will be the name of my table now that I have a demo, now that I have a table. This was the name of my temporary location. Real quick. And we'll call this thing. That's the name. Okay, that's interesting. What is it trying to tell me? It's not liking the fact that there's.
Looks like it's expecting a colon somewhere in the name.
That's supposed to be. It is expecting. That's the right way. Thank you. I don't know why copying from the other place. I will just was, and that's where the colon should be. Excellent. Thank you. And that will be this /staging. Thank you very much. And then the only thing I have to do is to click Run Job. What that will do is that it will go to that staging cloud search bucket that I created. It will upload the Python, the JavaScript class for the pipeline, and it will upload a configuration. It will then ask Dataflow to start a job using that configuration. So if I move, and again, this is running on Dataflow, it could be running on something else. If I go here and move to my Dataflow jobs, you will see that it failed, of course. But that there is a job that's been created. We'll go and see why it failed. And we will see that there is some errors here. Workflow failed. I didn't put the right. Okay, I know what I did. I will go and I will do something that's very, very bad. Especially, but I will give right. No, I will just give the right.
You had your first name in the bucket name over there.
Yeah.
Patrick. Now this one.
Yeah, you had P. Lecuyer in the
bucket name differently.
I have this and it. Oh, I put my
created
first name in the
unique,
configuration.
yes.
Okay,
Yes.
yes. Thank you. Got this. Let's go here. Topics. That's probably what happens because the permissions should be right. Here, we'll create a new job. So I need to recreate the same template. We'll go here. The table was project name, create, and I call the table tweets. This username, not just my first name.
And then staging you had.
Yes. There you go. So with this, you should be fine this time. Thank you for live debugging my code. That's really appreciated.
This
And
is
then
so cool.
We will. Well, it's more interactive. I mean, I could have had a video of this, but it's boring. You need to see me fail. Otherwise, it's boring. When I was teaching university, that's the same thing. My students always wanted to see me fail. Okay, so you see now that it's running, it's actually starting it. So I can come here and look at my data. And I will scroll down. So what you will see here is the actual graph. So I was telling you earlier that as we create that pipeline, it creates a graph, a series of elements. No, it's not a live demo if something doesn't fail at least once. If someone does a live demo and nothing fails, it was just scripted. It was not a real live demo.
Agreed. I've never had anything work in one go ever. Every.
And I mean, that's what's interesting. I mean, this is part of using those tools also. If everything looks too magic, people just don't believe in it. So back to this, what you have here is basically the visualization of the steps that will be running. So you will read from PubSub. It will be converting this to a table row, which is a construct in BigQuery. It will be writing this. There will be any insertion errors will be sent to another table, and it will write the data. You're seeing also here that I have some infrastructure matrix. So this is running. The worker pool is started. Right now, I'm running this on 4 CPUs. I've used very little CPUs. I have 15 gigs. I didn't need to define any of this. When I created a template, you didn't see me ask for any of that information. This is auto-scaling right now. So it's seeing the number of requests that I'm getting, and it's choosing the amount of infrastructure that I need to run it, which right now is the minimum amount of infrastructure that I can use for Dataflow because I'm cutting bits. That's an interesting question. It's true that I did not define the schema. What I'm doing here, and that's a part that I might have hidden a little bit, my script that I can show you later, which is not actually my script, that part I stole from someone else, takes the tweet and encodes it in JSON. So what I'm getting through PubSub are JSON objects. What the convert message to table row here does is that it will decode that JSON. And it will write the schema based on the JSON that it received. Very good question. What happens if the data is bad? Normally, if this was a production use case, I would have, when I created my BigQuery table earlier, I created it schemaless. I did not specify any schema because I'm lazy and this is a demo. I didn't define a schema. If this was a real use case, I would have defined a schema at that time. Since there was no schema defined, what BigQuery will do in this case is that it will define the schema based on the first element that will be written to the table. Again, very convenient for tests, not very safe for production. Don't do this in prod. But this is what is happening here. Now, you see here that there is a wrap insertion errors step. So what that does is that it takes the failed output from my write successful records. And if any of those records cannot be written because data is corrupted, the schema is not good, anything, it will write those records in a dead letter queue. So it will send this to another table as one single field, including the record that was not processed. So you will have a second table that will have all of that bad data, but the schema would have been set on the first message in this case. Does that make sense? And there are ways using Dataflow, well, Beam and using BigQuery to go and reprocess those errors to try to insert them the right way. One very interesting use case I had to work with a couple of years ago was for a gaming company that received game telemetry data from their video game instances. So people playing games, starting the program. Give me 1 second. My son just popped into my. Je dois faire un meeting en pair. Tu peux y aller, mon grand, je vais partir. Dans le salon? Okay, sorry about that. C'est bon, je fais ça. Okay, sorry about that. Again, work from home. What was I saying? Yes, so gaming company. That gaming company had an issue where they were receiving all of that telemetry data from their game clients. And their developers were not very... I can't find the right word. Their developers basically changed the schema all of the time. And that was normal. I mean, it was a small studio. They added stuff. They removed stuff. There was a lot of changing schemas. And there was multiple versions of the same client running, some of different platforms. And they wanted to make sure that they had all of the messages. So we managed to use this and dead letter queues and reprocessing to dynamically change the schema in the target BigQuery table as the schema was changing for data coming in. And we could do this for hundreds of millions of messages per second in real time. That's something that's doable and that scales. So there is a lot of very powerful things that you can do with this. Because that's a problem. And the common answer to something like that would have been to go and yell at the developers to just stop changing the schema and document it. But when you are in as fast-paced an environment as they are, that was not viable. And this is something that I really like about some of those technologies. You don't want to force people to adapt to the limitations of the technology. A developer that's writing that game, it's a small studio, it goes fast, they just broke 200,000 concurrent users. They don't want to worry about, oh yes, but I would need to change you don't want to worry about this. So there are ways to use those technologies to make the life of your developers easier. Doesn't mean that they need to do dumb things, which they will always do at some point, but you can still make their life easier. So that's pretty much it for this part. And just give me 1 second, because if I don't start the Netflix show for my son, he will come and yell at me. Not yell at me, but he will come ask again. So let me start this, and I will be able to move to the next part of the demo, which we'll do quickly. I'm because I don't want to go through two failures, and I know we're running out of time, and I've been talking for a while. Let's still go very quickly to BigQuery.
We don't have stop at 8, like people
Okay.
can stay after. So I'm married long enough, so my wife wouldn't mind.
Excellent. So if we go here, we go in preview. Oh, I'm not receiving data. That's interesting. I should be receiving data. I probably have something with the lack of schema that has been created, or something with my table name, regardless. So that would be the output here that you're getting the data there. But the interesting part here was not anyway to see the output. The interesting part was to go and see how we were creating that pipeline and be able to monitor that pipeline. Again, an interesting thing of data flow here versus running on another runner. For the job itself, it would run the exact same way. I was talking about the infrastructure being managed earlier. One thing that is really good here is that all of my pipeline is instrumented by default. So you can see that I have my logs at the bottom here. I can follow the logs. When it failed earlier, I was able to go and see the logs immediately in the same screen. I'm able to see the number of stages, what is running. If I expand this, I'll be able to see the details in the graph view. I'm able here and go and switch this to a table view just to see how many seconds is spent in each of the stages. This is the kind of things that a managed service will give you. So that's the data flow part of this. Now, last feed. Sorry, there's some. Was there a question?
Masa rahat son şikayet bize etmemişti galiba.
I'll mute him.
Yeah.
I'll mute him.
I don't think that's meant for us. Okay,
Right.
that happens also. So that's what we have. Another interesting feature that I want to show, and again, I don't want to go through other things that will fail, but I will still walk you through what we can do. There is a feature that allows you to integrate Beam into Jupyter notebooks. So we have a product, it's again managed in Dataflow, but you can do the same thing with any Jupyter. That's called Workbench. And what I did is, once it loads, I created this, and I have a Jupyter lab. I will just need to share this tab instead. That is linked with the Beam installation that I have. So if I go here and I open my tweet pipeline, part of this is mine, part of this is I stole somewhere else. You can go and basically document and write your pipeline in Python, in this case, directly in a notebook and share this and document this. All of the demo that I wrote can be found here. I can go and see how I'm actually connecting to Twitter, what I'm searching for pizza, as I was saying earlier. I can start and import and create my pipeline right here in the notebook. Again, I would not do a pipeline notebook for production. I would not do anything notebook in production. But as you are, the strength of products like this is to allow you to go to build and play with the data. And this is really the strength of something that's open source based like Beam. I mean, if you're using classical ETL like Informatica, let's say, you will probably not just go and play around with Informatica. No one does that. What we're trying to do here is to democratize this a little bit and allow you to play with it. So features like this will allow you to integrate. And let's say that a lot of what my team does is prototyping. So we have a customer that has an idea. I was talking about the gaming example earlier with banking examples across all industries. They want to show them what they can do, what we can do with the products. What we'll do is that we'll start workbooks like this. We will integrate with the workbook, add a few things. We can share those. We can collaborate on this. And at the end, as I document this, because the fun thing about the notebook is that I can document it also, I can go and just tell Jupyter to export this into a Beam pipeline. If I run it now, it will fail because I didn't go through all of my steps to show you, but doing this will basically just create myself an output pipeline that I can run directly in Dataflow from there. What I will do, so part of this, this is not packaged for now, but I will package that part of the demo because we have 30 minutes left. And I could go a little bit over, but not much. There's the kids that want to go to sleep. So I won't run through all of the pipeline. I spend too much time discussing other stuff, but I will try to share with Daniel the demo itself and examples to this so you could run it yourself. If that's okay. Does that work for everyone? Because that will take about 30 minutes to run and probably fail a few times, and it's probably not the best use of everyone's time.
That sounds good, yes.
Yep, sounds good.
Excellent. So we have a little bit of time left. I will share this with you, as I said. Any questions or anything that I did not cover that you would like to know? Any place where you would want me to go into more depth? Any questions or anything on this, or any other subject, to be honest. That's what I expected when I saw you jump. So what you missed, Daniel, I said, I will share, not right after this, because I need to package it, but I will share the demo with you. I will not run through all of the steps now, because it will take a little bit too much time. But I spent too much time talking, not enough time demoing. But I'm just opening for questions at this point.
Oh, cool. So the pipeline was not getting data because probably you're not consuming, or like?
The pipeline
know.
was not getting data, probably because I've set up my, what probably happened is that there is some configuration at the project level that probably prevented me from creating schema-less table from the data itself.
I see.
So that's probably where it failed. It was not inserting because I did not have defined a schema. This is a LAMP project I'm using for a lot of things, and I normally set them up in secure way. I probably did in this case, and it just failed because of that.
Cool. So this is the end of the presentation. This is
the end of the presentation.
Thank you.
I was just opening if there's any questions or anything that people would like me to get into more depth.
Guys, you can turn on the microphones. You don't have to chat here, so we can make it like true meetup after the presentation. Thank you so much. What I like about this, like, I like too many gurus. You're very approachable, and you feel as comfortable asking you questions and interacting with you. So much appreciated.
I'm happy. Happy for this. This is always, I don't want these things to be too formal. It gets boring if it's formal. I want this to be discussion. Otherwise, again, it's technology. It's fun. It's supposed to be fun. So I see that I missed a few questions. So how to control rebalancing distribution of data among workers to make it more even. So what you can control in this is how it will scale up and down the number of workers. The balance between each worker is not something that you can control because this is something that depends on a ton of different factors, including data size, including how it's split, including speed of each worker. So the balance itself is pretty much automatic, but you can define when you will create new workers, when you will scale down workers, the size of those workers, these kind of things. And yes, in batch pipelines, and you will see the same thing in streaming, you will often get worker outliers that will work less well. What you will be doing for this, so there is some infrastructure monitoring options that we haven't looked at. So we can detect outliers, we can detect badly performing workers, and basically just act on those badly performing workers. What will happen in that case is that normally we shut it down and Beam will just rebalance between the other workers. Because most of the time, this is a software issue that's causing this specific worker to misbehave. Sorry, I had missed another question. So once I configure the Dataflow template, the Apache Beam runner is also configured including Dataflow. Yes, exactly. So when you're using the template, it includes the Beam pipeline and all of the configuration for Dataflow, including the auto-scaling configuration and everything. You can fine-tune those. There was some advanced options in the template I didn't show. And you can go in the Dataflow job itself. If I go back here, share this tab. And I go into my Dataflow job. There would be ways here to go and change the configuration of this job to change all of those options here. I could clone the job to create a new one. I could snapshot and change the configuration. You see all of the execution details here. But by default, it will have done it with the default configuration or the advanced config that I put in the template config. I said config way too many times in a short period of time there, but hopefully that was clear.
Parnika has a hand raised.
Speak up. Yes, sorry, I missed that. Yes, Parnika.
Oh, I'm sorry, just every time somebody mentions any opportunity to about infrastructure monitoring tools, just my ears perk up. Can we
Okay.
those in this particular tool, especially with Dataflow? How would you want to see
So
runners doing well? Maybe perform some analytics on maybe what is the outlier, how to fix it in case.
exactly. So we have Dataflow jobs are instrumented by default. We have another suite of product that's called a Google Cloud Operation Suite, because again, we're bad at naming stuff, that allows you to monitor the status of those jobs on a ton of different metrics. This is where you would define the automation for what you want to do when you have misbehaving or misperforming infrastructure within the managed services. There is a lot of automation that exists by default because a lot of people who want to use automation, use managed tools, don't want to worry about this. But there is a lot of options that you can do to, again, choose. Are workers spending too much time? Do we have memory ballooning? Are we looking for leaks, for data leaks, things like that, and take action? Since it's managed product, again, it will automatically rebalance. So that's the kind of thing we can do. If you are interested about infrastructure monitoring as a data practice, though, because there is a ton of very, very interesting data use cases in monitoring, we also have some use cases for infrastructure monitoring using Dataflow and BigQuery and some other of our data products. We're using part of Dataflow plus Looker, which is our visualization tool, at some customers right now for log monitoring and even processing in logs, including AIML for NLP, so some specific narrow cases of NLP in logs to try to detect outliers. Also, all of Google's internal hardware monitoring for all of our data centers, which you can guess we have quite a few servers, go through Flume. So Beam, the internal version of Beam, is used for processing all of the data about everything that happens in all of an infra.
But she opened a good topic. It's not just the monitoring of the data flow pipeline, but in general, when we are switching from batch into streaming mode, the mindset changes. Before you can sign your message, you know when it arrives, you know how to complain and return. Now everything's different. Can you touch those aspects of operational monitoring? I pasted the link I found about these latency errors, but how would that tie in? And this is like agnostic of the cloud.
Yes, yes, and I'm getting to your question after William, okay? Because that's another interesting one. So as you're moving from batch to streaming, the nature of that's a shift in mindset. And Beam tries to abstract this a little bit by integrating batch and streaming. But the caveat to that abstraction is that now you need to think like streaming, even if you're just doing batch. So you need to go that extra step. The thing in streaming is that the matrix, the way that you will be thinking about your pipeline, is different because it is not because it is not the same. Sorry, I'll finish a sentence that makes sense a second. So basically, when you're talking about streaming, when you're talking about batch, you're thinking about the total time that it will take you to process all of your data. This is, as we were saying earlier, this is a bound data set, that there is a beginning and a end. And normally when you're looking at performance in batch, you have 2 hours to run that report. You will just throw hardware at the problem until the reports take 2 hours to process all of that data. Streaming is different. Streaming, you don't know when the data starts, you don't know when the data ends, and most of the time you don't know in between how much data there will be. Some use cases are more predictable than others, but there is a lot of very unpredictable cases. So when you're talking about performance in streaming, you are thinking about how much capacity you will need to process one piece of data, not to process the old data set, because you don't know the size of that data set. And this is what you will be scaling on. And how long do you have? How long can you afford to spend to process that one piece of data? This is what will introduce the concept of the total latency of your pipeline. So if I'm receiving data in real time and I'm spending 10 seconds to process that data, my data output will be 10 seconds late. In some cases, that's perfectly fine. In some other cases, that is a showstopper. There's no way that this will go. So as you are looking to this, you will need to figure out what's the latency that your system can handle and how much you will do this. And you will look at this per piece of data. The other thing, and there are some metrics that we might look at here. Actually, I had this, I think, in the table view here. So you see here, there is something called the wall time here. The wall time is basically how late Dataflow, or Beam, because that's the Beam runner, that's not a Dataflow feature, everything has this, is processing that data. So that's the latency between when the data came in and the moment that Dataflow or that Beam had the time to process that data. As this starts going up, this means that your latency is increasing. That means that you're processing older and older data. This might mean that you need to auto-scale up. You might need more processing power. You might need more memory. You might need some. But these are the metrics you will monitor. Something else that you need to keep in mind that we don't worry a lot in batch is that your data might be coming in out of order. There is a lot of things here that was a simple use case. So I'm assuming the data gets in order. And if it gets out of order, it's not that big a deal. There will be some use cases where data that is out of order, especially data that arrives late, might be causing issues. Without going into the details, because this would take another hour to go through, but there are features within Beam to handle those type of streaming specific use cases. So let's say examples. I was talking about the gaming use case earlier, though, those game client telemetry they were receiving. Some issues they had in some cases is that some game customers got disconnected or had some ports blocked that did not send the telemetry. And all of a sudden, things unblocked, and they received 10,000 messages from one single client. That represented, let's say, the last 45 minutes of gameplay. That can skew stats. You can't take this as events that happened right now, but that also changes the past because, again, this is old data. There are different strategies that you might use to do this. Do you want to recalculate what you did in the past? Is this important enough? Do you want to drop it? Do you want to create a new version of it but keep the old one? And Beam offers you all of the options that you have to handle the uncertainty around when the data will arrive. Because when we think about streaming pipeline, and that's everyone does that, we think about data coming in real time and processed in real time, but reality is much messier than that. So you need those features to be able to deal with those messy things when they happen. This was a little bit long-winded, but did this answer your question, Daniel? You're muted.
Whoops, you're muted there.
Sorry. Yeah, it was, and I think it's useful for other folks trying to switch from batch to streaming because it's a mindset change, and that's what
it is a mindset
customers are objecting. Like, how do I know it finished? Like, for instance, now pipeline's working, but data is not coming, so there is some monitoring that needs to happen. So,
and using those same tools you were just describing, the details you didn't want to go into or whatever, can you also use that to replay easily certain event streams?
Yes.
Like, let's say I'm developing and iterating on something, and I want the events from 805 to 809 replayed over a few times while I try different things. Is that easy to do?
Yes, that's super easy to do. That's a built-in feature, and that's something we use again when prototyping all the time.
Yeah.
So I had a few questions in chat. So orchestration tool, So there is, in any orchestration tool that can orchestrate starting Java or Python jobs would work. Within Airflow, which is an Apache product, is very, very popular if you have more complex use cases. Airflow is a great product. It's an awesome product. There is some complexity, though. So if you're looking to start one job every day, you might not need Airflow. It's complex orchestration. Cloud Scheduler, which is basically just a cron in cloud, also works very well, as Francis was saying. You mentioned Airflow or Composer. Airflow is the Apache product. Composer is the Google Cloud Managed Service. So if you want to run a Airflow on Google Cloud, we have Cloud Composer that allows you to do that. So that's for the orchestration. Another very interesting subject, by the way, if at some point you would like to hear about job orchestration, is something else that me or someone on my team could talk about. That's another very interesting subject. In the event of troubleshooting Dataflow pipelines, where does log to be looked into? So all of the logs, if this is within Dataflow, basically, if we go back at the Beam level, Beam will log to the runner's default logging engine. So if you are running a Beam pipeline in Spark, it will log wherever Spark logs. If you're running it Flinks, wherever Flinks log. If you're running it into Dataflow, it will go to Stackdriver monitoring, Stackdriver logging. So what you see here, if I go in my thing here, and I open this panel, I should just make my window bigger. Okay, so you see this log here. This is in Stackdriver monitoring, which is our Google Cloud's monitoring tool. So if I open this in a different tab and I switch the tab that I share, it used to be called Stackdriver monitoring. It's called operations logging now. Again, changing names, and but you will see that it is in the Dataflow specific log there. Did that answer for the logging? And now eventually my laptop will display this, but this is the log Explorer interface here. Other questions. So for data problem, yes, handling data problems and errors inside the pipeline and sending to dead letter queues is the best practice for this. You normally don't want to drop data. There might be some use cases where you do, but it's rare. Normally you don't want to drop data. The pipelines in Beam can be instrumented with error processing and to send it to dead letter queues. And those dead letter queues you can then analyze, solve your problem, or replay them as we were talking from Jonathan earlier, and do this inside. That's to monitor the data issues. This will also integrate with with operations monitoring now. We removed the Stackdriver name. You can also create alerting. So if you start to having an increase, let's say, of data errors, there might be, it's good to keep them in dead letter queue, but it might be a symptom of something else. There is ways in Dataflow to just instrument this and do a modification and actions on this. I know that I missed some. What did I miss a question from someone?
Folks, you can unmute yourself.
Yes, about do you have any suggestion about how to test data pipelines?
Oh yes, that's the one. Okay, that's the. So again, this would be something we could talk about for hours. There is unit and integration testing tools within Beam. So you can create test pipelines the way that I normally do it, but with the big caveat that a lot of the work that I do, again, is prototyping, is early stage stuff. This is not something that will go prod. Is by running unit tests on each of the transformation and running not automated integration testing, but manual integration testing of the whole pipeline using known data. So I basically just have a known data set. I know what's the output. I run it through the whole integration pipeline, but I write unit tests for each of the individual transformations I do. There are ways to automate this using standard CI/CD, with all of the caveats that testing is not as simple, and it's a little bit messier than in reality than in theory. But there is tooling. I would say that this is the testing tooling within Beam is not the part that I'm the most of an expert on. But if you would like to talk to someone that can dive more deeply into this, just email me and I can put you in touch with someone.
Yes, we were able to use the unit function and the unit test provided by the pipeline. We were able to CI/CD everything and automate testing
Cool.
and deployment with all the permission testing and sending data from one end to the other and checking the database. But that's a lot of work. So I was just wondering if you had a more direct way or
no, there's
things.
Yeah, it is a lot of work. I think it's useful work though. It's not interesting work, but it is useful work. I'd like to hear more about your setup, because it looks like you have something pretty interesting going on.
Yeah, happy to discuss it with you.
Cool.
Any other questions?
Okay, so what resources would you suggest exploring streaming pipeline on GCP? So what I would do, if you want to start with Beam, if you go to the Apache Beam site, there is excellent documentation about how it works. There is something, and let me show you the doc, actually.
Word count example, everybody's using that one.
Let me show you.
And then register for Apache Beam conference summit.
Yeah, there's the Apache Beam Summit coming. The mistake that a lot of people do when they look at the Apache Beam documentation is they will look there, they say, oh, I want to run this in Java, and they will go and they will say, okay, here's the Java SDK, and they will start trying to understand the API. This is what any developers would do. This is what I did the first time also. I went to, okay, show me the code and show me the API. There is a general section in the documentation here that has something that's called the Beam Model Basics in the Programming Guide. This is very, very important. This explains the concepts behind this. Everything that I've mentioned, how do we transform between singletons to collections? How do you do type? How type is managed? How do you do all of the strategies for out-of-order data? All of those details I said earlier that I would not get into, because I will still be here at midnight if I go into all of that, are explained in that. And as Daniel said earlier, a lot of this is more about about shifting your mindset versus the complexity of the code itself. You saw that the Java code I showed you earlier didn't even look like Java. So understanding the concept is very important before you go into the details. Otherwise, you will do what a lot of people do. You will get into the API. You will get confused by something, and you will just say, oh, this is way too complex, when it really is not. You just need to understand the concepts before you dive too deeply.
Perfect. Thank you.
Can I ask you
Yes.
about? So we're talking about the streaming versus batch, legacy versus new. So Google's recommendations was, if you have just a Hadoop cluster on-prem, migrated to Dataproc, or like to reduce the. But some customers, and I was watching this talk from Telos, they decided to rewrite everything they had to be. What is your approach when you would let customer do that versus just use what they have, use managed Spark?
That will depend on a lot of different factors. The approach we have at Google Cloud. So, and this is a philosophy we have, is that we want to support the customer where they are in their cloud journey. For some customers, this might be a pure lift and shift, and we say sometimes even pure lift and shift to VMs, which is not a very serverless thing to say, but this happens, and this might be the right thing to do. Customers, though, needs to be aware that there is a hidden cost to lift and shift. There is some value in transforming. And this is what teams like mine will do with customers, try to figure out, okay, what do you want to lift and shift? If you're, and these will be general examples. I mean, every situation is different. But if you have hundreds of reports running in Hadoop that you're happy with the performance, that those will not be changed in the foreseeable future, that it will stay the exact same, that you don't want to start innovating on this, my take would be just lift and shift. There's no reason to go and reinvent. If you have existing on Hadoop that you've lost the internal knowledge, because that's something that is often an issue with people who have legacy stuff. Everyone who wrote this have left the company and no one has any clue how any of it works. And now you start lift and shifting and you realize that you don't understand what you have. This might be a signal that it's time to start and not reinvent, not rewrite everything, but at least modernize where it makes sense. Most, in reality, cases where people go full lift and shift or full re-architecture, it's rarely one or the other. It normally falls somewhere in the middle. You will find the right workloads to migrate. And again, Dataproc is a very good Hadoop or Spark as a service option. You can do this. But for some others, you might start and migrate. It really depends from customer to customer. I know that was a little bit of an it depends
No,
answer.
it's
It's
awesome.
not great.
It's awesome. I will share the context in the chat, the talk that prompted me to ask you, because like I did not understand the context, but I love that. Okay, when Kelsey Hightower was guest, he says the software gets abandoned, like nobody knows how to use it, and that's the problem. That's when you decide to do that. And then, like, if I can ask you, like, I really like the changing schema and then dynamic example that you used in gaming.
Mm-hmm.
Can you elaborate on that? That's a design pattern that we could use. Is it documented somewhere?
We had published something. It's been a couple of years, so I would need to find the links to that. Let me find it and share with you. But that was a very interesting design pattern. There were some things that we've published. There were some things open sourced actually around this. I just need to find this and talk to the person on my team who wrote this at the time, and I'll see what I can share.
Thank you so much, because JSON is always changing. One thing I liked about XML is XSD schema. It guaranteed the contract, so you wouldn't handle the junk. Now, GraphSQL has that promise, but most of the JSON is unreliable. Mm-hmm. And so it's a problem that you have nonstop.
No,
and then
exactly.
you talk about dead letter queues. Like example use is dead letter table really. So when you say queue, it's a generic concept. You're not talking about pub sub queue for returns.
It could be either way. So it could be a table.
Mm-hmm.
In some cases, we actually use pub sub queues. Mm-hmm. Because there are some cases where we want to reprocess it right now. Mm-hmm. Again, that will be very use case dependent.
Okay, that is cool. So I invite everybody. So the recording will be out to go again through these 5 examples you want to play. We'll share the slide deck where links to examples will be. You don't have to rush to make this notebook executable whenever.
Okay. Excellent.
And then register for the Beam Summit. And then regardless of the cloud you're in, I know this was painted like with Google colors, but it's donated to the open source. And John, you can run the same thing. I think it's Kinesis Analysis. That's the name. Analytics, that's the name they use over there. And IBM Streams and IBM Cloud, and Alibaba is also using it. So I'm really honored and happy you were here to share with us and show everybody how easy it is and where the landmines will be.
Yeah, and thank you for having me. Super happy to have been here. And again, feel free to reach out to me anytime. Always happy.
And we have to do raffle as well. So while I prepare the names to see you guys continue asking questions.
Yeah, concerning the replay feature, reprocessing and schema change dynamically, we have this. Okay. We have a team that built this, exactly what you mentioned.
Okay. I saw your email. You're in gaming industry also, right?
Yes.
Yeah. So that's a common problem in gaming.
Let me find the names. And if you didn't do the survey, put your names here. I'll do wheel of names soon as I'm searching for.
Talking about the gaming use cases, especially around data, gaming companies have extremely interesting use cases in tech in general. I work with companies from a lot of different verticals. All of the banks think that they are advanced and do advanced cool stuff, but they have nothing on gaming companies, honestly. Gaming companies are years ahead of anything I see in FSI.
Is there any plan to integrate some kind of API to, let's say, do some data observability and data lineage inside Beam?
Yes, there is. With the caveat that I don't know how soon, because data lineage is messy. I used this several times, but that's the reality with data. But yes, there is ways you can already. So Google specific, not open source, but there are some hooks with data catalog as the Google product that is coming up. The goal is to have the same kind of hooks with some open source tools that will do the same. But again, the problem with data lineage is that there is no good standard right now to do this, and this is what is slowing this down for adoption in open source. There is just not a good way of doing it at this point.
Yeah, so far I saw a few presentations from private company like Monte Carlo and Prefect that seems to have tools. I wonder if you know these and if they integrate well with BigQuery, Dataflow, and Beam.
I don't know the specifics. I would need to look before I can answer more in details. But reach out to me, Al, and we can have a conversation.
Yeah,
I'm almost ready with the names. Oh, mistake. Okay, so let me share the screen. I spin the wheel by mistake, so that doesn't count.
Stop sharing.
So if anybody forgot to... Am I sharing?
No, I don't see it.
Okay, if anybody among you forgot to put their name in the forms, so these are the names I have. Can you see them? Anybody doesn't see their name? I added Patrick as well. So this raffle will allow you to win any of the mining products, books, courses, whatever they have. And I really love them. Anybody? Are we missing some names? No? David?
David was saying he's not in or he's in? Which?
Let's see. Anybody else? Last time I rushed. People were, come on, that doesn't count. For some reason, I need to put... Why is it not taking?
David?
I know, it's not taking. Come on. Why is not letting me edit the names? Okay, here. Any other name?
Well, I think that you have like several names on the same line. That's what's happening there.
Oh, yeah,
The
there
third
you go.
line.
Yeah. Yeah.
My time to debug stuff live now, so that's good.
There we go. Yeah, don't put me in there, Daniel, because I already won once.
But is it from? I pasted it from the.
It's me. It's okay.
You see, it's a long name.
Yes.
Oh,
So
sorry,
it's
it was
a real
okay.
name.
Sorry,
So yeah, it was a paste, but then after that I kept hitting enter. Anybody else who wants to be in here? You have good odds of winning products.
Okay,
and I just
now you've got
$50.
two Davids. That's the problem, I think.
David, is that the same David? David Saul?
Yeah, I think there's just the one.
Oh, I didn't recognize that you're the same guy.
Yeah.
Anybody else? Anybody else? Really good odds. Like you will not have to spend like $40-50 on their books. Okay, Branick. So let's wish you good luck. Spin. Madeline, are you with us?
Congratulations.
Are you with us or you left?
Oh, she's not on the list right now.
Okay, if you are not here, I will do the draw again. You have to be here. This was a perk to stay until the end. Okay, remove the name. Ta-da!
But you're 6 minutes late, Daniel.
I told you I'm not in a rush. My daughter came from UK, so my wife's happy. Ta-da!
David.
David. And that's
David.
fair and square.
Yeah.
I
You're not
got
listed twice.
lucky.
So David, put your email address in the chat here, and then we'll introduce you to nice folks for Manning. You can go to their website and choose anything. And John, I don't think you took a book last time, so you won in a recent meetup.
Oh yeah, I have one. Yeah.
You got one. Okay, I
Yeah,
didn't
yeah,
see you fulfill it. Cool. So that's all from me for this month. We don't know what's going to be cooking like upcoming months. We'll surprise you. Whoever replies that wants to do it. Patrick, thank you so much, and look forward to learning more from your team. And
Excellent.
then, guys, if you're looking for work, so he's hiring. And
Yes,
keep
I'm
contacting.
hiring someone with a application modernization profile for now.
Any other closing questions? Anything else?
Thank you very much.
Thank you.
Thanks, everyone.
Thank you. Stay
Bye.
safe. Enjoy the spring, and hope to see you soon. Thanks again, Patrick.
Okay, did you get David's email there, Daniel? Yeah.
Yes.
Yeah, make sure you get that.
Copy, search.
Okay.
Perfect.
Great.
Thank you very much.
That was so good.